Good morning to all. I am Gomadanayagam from Ramco Institute of Technology. As one of the coordinator of this webinar series, Future IT 4.0, I welcome you all for the today's session on robotics and implementation approach. On behalf of management, principal, HOD CSE, and my own behalf, I welcome our resource person, Dr. B. Bensujin, Professor and Head of Section, Electrical and Electronics Engineering, NISFA College of Technology, Oman. It is a great honor for me to introduce Dr. B. Bensujin. He did his UG Information Technology in Sun College of Engineering and Technology, affiliated by Manonmaniam Sundaramar University in LI, and he completed his PG Computer and Information Technology in MS University, Tirunelveli. He did his doctorate in Karunya University, Coimbatore. Currently, he is working as a Professor and Head, Electrical and Electronics Engineering Department of NISFA College, Oman. He is having 17 years of working experience in the academic field. He received various awards and got funded project from Government of Oman. He has published his research work in various refereed journals and conferences in the area of robotics. We are proud to have you in this session. In this occasion, I welcome Dr. B. Bensujin. Welcome you, sir. Next, my heartiest welcome to faculty members, research scholars, PG and UG students from various engineering colleges, arts and science colleges, and my dear students from Ramco Institute of Technology. I once again welcome you all. We all know robotics is an interdisciplinary research area which combines various engineering departments like EC, Electronics and Communication Engineering, Computer Science and Engineering, Mechanical Engineering, as well as the Electrical Engineering. The main aim of the robotics is to design an intelligent machine which assists human in day-to-day life. So many of the researchers, they are doing the research in the robotics area nowadays. I hope this session will be useful to all level of participants. We request participants to mute your audio and video, which will help to save your bandwidth, and you can ask the question through the chat box one by one, which will help the resource person to answer your question very clearly. At the end of the session, feedback link will be shared to you through the chat box, which will active for the another 15 minutes. Kindly fill and get your e-certificates. With these few words, I hand over the session to Dr. B. Bensujin.
Thank you, Mr. Gomadanayagam. Good morning, everyone. Hope you are doing well and good. Okay, thanks for giving this opportunity, and I thank the management of Ramco Institute of Technology, and thanks all the colleagues, staff, and the students, those who are participating for this today's event. Okay, so anyhow, without wasting any, it's not audible. Can you hear me, all of you? Hello, can you hear me? Yeah, fine. Okay, let me go through it. Okay, I will start. I don't want to waste the time. We'll just directly switch into our today's topic. I'll just open my screen. Just bear with me for a minute. Yeah, as hope you could see my screen, all of you, right?
Sujin sir, your screen is not yet shared.
Yeah, I'm sharing now. Yeah, can you see my screen, sir?
Yes, now it's okay.
Yeah, fine, okay. So as in the introduction part, Sir Gomidi told, like robotics is an interesting area and it is going through a lot of researches and everything. I will just give you a glimpse of what is robotics. And actually, I would like to apologize you all. Actually, I planned it to give you around 20 minutes a practical approach, how to develop the robots, how to implement it, and what are the different components, everything in a hardware based. I actually wanted to explain you, but due to some critical issues because of this COVID-19, yesterday we have to take some serious actions to close my lab. So that's why I couldn't do that one. Anyway, sorry for that. In future, in case if we get another chance, I will try to do that for you, okay? And if you are willing, okay? So now let's just move to our topic. Why we say robotics is more important and it's playing an important role in today's world. Let's have a small look into it. Then we will move to about the different parts of robotics and everything, okay? And as you all aware that we are into the 4th industrial revolution now. We crossed 3 industrial revolutions, which covers the steam engines developments, the electricity which comes to the industries to provide the mass production, then the digital world, the invention of computers, emails, telecommunication networks, and all those things. And now we are into the 4th industrial revolution, where a lot of the biotechnology has a major impact into it, and the robotics with intelligence is having a main factor, or it's playing a main role into the 4th industrial revolution. That is why the robotics is too much important that we should be aware of, okay? Now, to go into the topic, okay, robotics has been developed in the late 19th century itself, but now in the 20th century, we found that robotics are playing much important role with a lot of intelligence. It means that the robots are going to do a lot of things by its own. That is what I say. Robots are doing much things with intelligence. Okay. So now let's move to the robot functionality. The basic functionalities, 3 functionalities the robot has. It's just, it will be very simple, like a simple thing for a computer engineer to understand. The same thing we have in the computer also. Here the robots have the basic 3 functionality. The first one is sense. The robot has to sense, like a human, it has to sense to the environment. What's happening in the environment, what's going on with the environment, it has to sense. That will be considered as the input for the robot. So all robot should have the ability to sense. This sensing mechanism or the sensing facility can be obtained or can be imparted into a robot through different kinds of sensors. At the end of the seminar presentation, I will explain you with some sensors which can be used into different kinds of robots. So this is the input part. This is the main thing what we should have. The main functionality of a robot, it should have a sensing part. Then once it started sensing, it will give that inputs to the microcontroller where the thinking process will happen. It's like our brain, when we sense to the environment outside what's happening, then immediately our brain will start thinking, or it will start processing about what action I have to take or what decision I have to do. So the same way, in case of robots also, we'll be having some microcontrollers. Different kinds of microcontrollers are there, and different types of microcontrollers will do, or it can perform different types of functionality, different types of operations, we can say. So the robot has to start thinking using these microcontrollers, microprocessors, okay? Then after that, once it took an decision, then it has to act. So the act, we can say it is like an output devices, something it is going to do or complete the task. The act performance is going to complete the task. So these are the 3 functionality all robots will have. It will sense to the environment, Based on the input, it will process it, then it will act upon it. Then let's move to the subsystem. So based on these three functionalities, robots are classified with three subsystems. One is like perception capability. The first one we have is a perception capability. It is nothing but it is to sense the thing, sensing the environment. So to adapt to the environment using some sensors, okay? All robots, almost all the robots which are used for very good purposes, we can say, they will be imparted, they will be inculcated with the different types of sensors. Broadly, we can classify into internal sensors and external sensors. The sensors which are kept inside the robot to move, to understand the joint movements, to understand the internal part movements, we call it as an internal sensors. And the external sensors are to understand what is happening inside the environment, like some sensors to understand whether any obstacle is in front, or to understand whether any person is in front of me, something like that. We can have some external sensor also. And the second part is the controller. As I told you, this is the processor, the microcontrollers or the microprocessors. We can use it over here. This will be considered as the brain of the robot, which will perform the think operation. Then the third one is the mechanism. The mechanism is the output part. It is going to complete the task. So here we call it as actuators, the mechanisms used in robots to perform a desired task. We call it as an actuator. I will just show you a video in the following slide how an actuator will work. There are three basic kinds of actuators available in the market. So one is electric actuator, the second one is pneumatic actuator, the third one is hydraulic actuator. The electric actuators will give you the precise movement. If you want to have your robot with more precise movements and to have like accurate decisions, accurate movements, then it is preferably going to go for the electric actuators. These are controlled by the electric motors, the electric actuators. Then followed by electric actuators, we have pneumatic actuator. The pneumatic actuators and the hydraulic actuators are same in the working principle. It works like the mechanical structures using piston and cylinder, which have been used in the IC engine, something like that. It will work, the pneumatic and the hydraulic actuators. But the main difference between the pneumatic and the hydraulic actuator is the pneumatic actuator will work based on the compressed air, but the hydraulic actuator will work based on the fluid which is inside the piston, cylinder and the piston concepts there. Okay, so these are the three actuators. Let me just show you a video like how the electric actuator will work. Okay, this is a linear electric actuator. Just have a look into it. Hello? Huh? So this is the internal architecture of the actuator. Actually, this work like a nut and screw mechanism here. So when the electric motor rotates, the gears will give the movements to a screw, so which makes the nuts to move the actuator in the opposite direction. When you may imagine like how a nut and bolt moves in two directions. This is the working principle of the electric actuator. Okay. So just let's move to the types of robots what we have. the first classification, which is called unmanned marine vehicle. This is types of robots are used in the water. Mostly, you can you may heard about the water inside the sea. Lot of researchers are going on the ocean. Lot of researchers, underwater researchers, are going on. So, for the purpose of underwater researchers, this type of robots are used. USV or UMV are used. Too many research ideas are there for the underwater researchers. Like if any of you, any students, if you have an interest, if you feel like you wanted to do something in robotics, you can prefer this underwater robotics, which provides a lot of impact. Even I can give you a small idea, like, a few years back, a couple of years back, you might maybe your professors might have heard about, like 2-3 days the internet connection has lost in the southern part of the India, because of a cable got cut, which is the underwater cable got cut actually. Because of a ship moving through that one. You know that a lot of submarine cables, underwater cables are there, which takes much amount of data from countries to countries and to one place to another place. So to protect this cable, not only can get damaged by the ship, this also can get damaged by the big shark fishes. Big fishes, when they see these cables, they can bite it and they can cut the cables also. Okay, so to prevent this one, lot of researchers are going on. And another type of problems we may face with the underwater cables, like hackers can go there and they can also tap the information. They can tap the cable and they can also take the information. So to prevent all type of this type of cables from getting damaged or for getting from unauthorized access, we can do a lot of underwater robotics. The robot can go inside the water instead of a human going inside. Instead of a person going inside, a robot can go inside, and it can able to sense the thing what is happening over there. It can able to read the information. It can give any information to the ground station which is there with us. So this type of research is also possible. And also you might have heard about tsunami. You might have heard about a lot of incidents happening from the sea. So for such things, we can use some robots which can work with the underwater or on the surface of the water. So this category we call it as an unmanned marine vehicle. So the next category we have, which is unmanned ground vehicle. This is the normal robots what we see in our day-to-day life. Even now, you might have heard about in India itself, you can see a lot of robots has been developed to provide the sanitizers, to give information about the COVID-19. And most of you might have seen a video from China that a robot is going to each room where the people, those who got affected by COVID-19 are staying. So these type of robots, we call it as an unmanned ground vehicle. So these robots, the movements of this robot will be a tracked movement. Tracked movement in the sense a line will be drawn, a track will be there. So the robot will follow that track using some sensors. It will follow the track. Then wheeled robot, it will have as like normal tires. It will have some wheels. So using that wheels, it will move. Then the other category is legged robot. It's like a normal human being or like an animal. It may have 2 legs. Sometimes you can see some dog robots which has 4 legs and some other mobilities. So when I speak about that dog robots, I can also tell you some research. Even I am also working on that one now. Which has it works like a dog. You all know that the police department, they use a dog for searching the robbers and searching the criminals. Okay, so now these dogs can be replaced by a robot if you can put some type of sensors. We have some kind of smell sensor which can understand the person's smell, or it can able to read it can able to sense the smell of a person. So smell sensor, you can also use it. So you can use some smell sensor to understand how what's the criminal is there. So you can also use the robot there. Okay, for instead of a dog, you can use the dog robot. So the next category is the unmanned aerial vehicle. So this way robot is a type of drones. So this is a normal category we are coming across, actually, the drones and everything. We call it as an unmanned aerial vehicle. Drones, some flights without the pilots, we call it as an actually unmanned aerial vehicle. Then we have automated guided vehicle, AGV. These are used in the industries where we use to lift the option of lift some products from one place to another places. The last one is called as the humanoid robot. Humanoid robots are the robots which will work like same as the human being, which will sense like a human, which will work accordingly like a human. I will show you a video about the Sophia robot. Most of you might have seen a Sophia robot which will work like a human. So at the end of the presentation, I'll show you a video. Okay. Now, I'll just go into I'm going to speak something about the unmanned ground vehicle. Okay, how we are going to understand how how we are going to put the intelligence into this unmanned ground vehicle. Okay, so usually for this robot, it is going to move in the environment. It is going to move towards the environment. Okay, the environment can be two types of environment, like it is a static environment or a dynamic environment. Static environment in the sense that the environment will be kept same. It will be same. If you have some obstacles, it will be left same. No, the obstacle will not change. It will be in the same place. There will not be any changes in the obstacle. So that we call it as a static environment. So once if you train your robot, once you train your robot, the robot will start working according to the same thing. It will not change its path or it will not move away from the path. It will follow the same path what you are training. Okay, so to do that to train your robot in the static environment, you can use an algorithm called Dijkstra's shortest path algorithm. This we all know. It's a very simple algorithm and the easiest algorithm we can implement into a robot. Okay. The next one is the dynamic environment. The dynamic environment, it means that today the obstacle will be in one place, tomorrow the obstacle will change. So immediately the robot has to think by itself and it has to change its direction also. Based on the obstacle, it has to change the direction without hitting the obstacle. So to implement a robot using, if there is a dynamic environment, the best algorithm can be used is the A-star algorithm. We can use the A-star algorithm to implement to implement a robot in a dynamic environment. I will just show you a video how the path planning is done with the MATLAB for a robot, which when there is a dynamic environment. Okay, actually in MATLAB we have a toolbox for the robotics, so you can use that one. Okay, a small robot here. This is the starting point mentioned, and the end point is mentioned. First, you have to import the map. You have to import the environment map. It can be imported by an BMP image, or it can be imported through some sensors also. So from that map imported, you have to plan a path. Okay, there is an algorithm we have in the MATLAB to plan the path. So now this is the environment. Okay, this is the environment map. Okay, this environment map is imported using a JPG image. We can also import in the real time if we have the hardware which can be embedded to the MATLAB program. We can also import that map. We can also import the map from an external sensor also, through an external sensor. Okay, then we have to write a program here for the floor plan, which is the occupancy grid. We are making the occupancy grid here. Okay, once it is done, yeah. Is it fine now? Can you see? Hello? Can you see now? Yeah, I will do it. Can you see now? Hello? Fine, fine. Okay. Did you have a look into that MATLAB program which I showed, that video? Or shall I repeat that one? Hello? Excuse me? Okay.
You can start. Repeat it, sir. Repeat it.
Okay, fine, fine. Okay. So I'll just explain you about this program, how we can do path planning using MATLAB. Okay. Now, I'll just show you the video. Okay. I'll show you the video. I believe that you can see my screen now. Okay, fine. Mr. Govindinayagam, in case if you couldn't view my screen, just give me a message in my WhatsApp so that I can stop
sure,
it.
sir.
Okay, fine. Okay. So now there is a robot. Okay, we have to define the start position and the end position. So this is the start position I have defined, and this the end position is defined. Okay, so 3 steps we have to do it. Okay, first when we plan for the path, we have to do 3 basic steps. One is we have to import the map, then we have to plan for the map, then we have to make the robot to follow the path. Okay, we have to make the robot to follow the path. So now here you can see, okay, the map can be imported. The map first part is that we have to import the map. The map can be imported from any images like a JPG image, or you can have a BMP image. You can import the map, then you can create the occupancy grid. So once the occupancy grid is created, okay, once the occupancy grid is created, we can create the path now. Okay, so now this map can be, as I told you, it can be imported by from an image, or this also can be imported through some sensors also. This can be imported through some sensors also. Okay, we can, as we are going with a dynamic environment, all the time we cannot import it through an image. It has to depend upon some external sensors. So this also can be done by an external sensor also. Okay, so once we imported the map, then we are deciding the path using an occupancy grid. We are creating the occupancy grid, and using that occupancy grid, it will understand where the obstacles are there, where the free path is there, and it also will define which one is the shortest path, because we are going to implement the A-star algorithm. In the A-star algorithm, you know that it will take the vertices, and from the vertices it will understand which is the low cost, and according to the low cost path, the robot will follow. So this is the working function of the robot using a path planning using the MATLAB. In the MATLAB, you can see some algorithm called as pure pursuit program. There is a program, there is a module called a pure pursuit module, which will detect the or it will create the path for the robot for us. Okay, so after you do this one, it will decide the path, and the robot will move into the occupancy grid. Okay, so this is a small demonstration how it can work with, how we can do it with MATLAB. I will also show you a video, okay, how the A-star algorithm is implemented in robotics inside an industry application in China. You can see into this video. Okay, yeah. So how we can put the intelligence into, so just we have seen how we are going to put the intelligence into the UGV. Now let's see how to put the intelligence into the humanoid robots. Okay, so the humanoid robots, as I told you before, this has to see what is happening in the environment. It has to sense, it has to hear, and when you speak to the robot has to respond to you in a very good way, in a nice way, as like the humans do. Okay, so in order to put, if you want to put intelligence into a humanoid robot, you can use some type of programming techniques which is called as TensorFlow, and also you can use the Singularity Net. Okay, TensorFlow is an open source software. It's freely available. You can download this library and you can able to write your own program to put the intelligence into your robot. Okay, this TensorFlow can work with Raspberry Pi, so which is the less cost microprocessor type, a small type of computer we have. So you can use that Raspberry Pi also to develop a small simple humanoid robots using TensorFlow. Okay, whereas Singularity Net, you have to create a login, you have to pay some money, so they will provide you the access there. Okay, I'll just show you a small video how the humanoid robot is working. This has happened in India, okay, but the robot name is Sophia robot. Okay, let's move to the next one. Some of my controllers which are used by me in the robotics projects, I will just bring to your notice so that it may help you also. The first one which I am using is the Raspberry Pi. You might have come across, most of you might have come across, and even you may be using this type of microprocessor type. This is actually, it's very cheap, and it gives like a lot of functionalities it is having. So the next one is the PLC, Program Logic Control. This is a powerful microcontroller which I am using in many kind of robots. I'm developing the robots what I am developing actually. The PLC is also used in the industrial purposes. In most of the industrial robots are being controlled by the high power PLCs. It gives accurate values, and it can work with different types of environments also. Okay, then the VEX controller. This is another type of controller I am using. This controller is also programmable using C programming, VEX blocks programming. and also it has the what we can say, the robot can be operated using a remote controller also. So it will work autonomous, or it can also will work based on the remote controlled, and some another RTOS supported controllers also I am using. So these are the different controllers are being used by me. Okay, I'll just take you to the different type of some few controllers, okay, which is doing the think process. This one, the first one is the Arduino. Even I don't suggest anyone to go with this one, but if you are a beginner level, you can go with the Arduino. You can use Arduino to to develop a program, but you cannot put much of intelligence into it. It will not decide. It is very difficult to write programming into it to decide by itself. Okay, but the next level is the Raspberry Pi. You can see some pins over here. Okay, and I'm really sorry for showing these things through the pictures if I couldn't show you in real time. Okay, in future, in case if there is a chance, if there is a possibility, we will do it. I can show you through the practical thing how the pins will work, what are the things. You can see in the picture, you can see some pins over here which are used to give the input to the microcontroller, and also which are used to give the output to the different actuators, to the output devices. Here you can see the pins. These will get the input and it will give the outputs. This sides you can see some USB ports are there. This is the network port. RJ45 jack is here. You can connect your Raspberry to the internet, so that you can use the same board as for a lot of IoT projects also, because this also have inbuilt Wi-Fi modem there. So automatically you can use it for a lot of IoT projects. And you can see an audio jack, where you can connect your mic, which can use or which can allow your robots to hear to the people, to sense, to hear what they are speaking. Accordingly, whatever you hear, you can use a lot of Google APIs, and you can use another APIs to natural language programming you can use, and to convert the voice, what you hear, to an action through the output pins you can do. And you have an HDMI port, which can be connected to a screen, and you have a port here, which is used to connect the camera. Actually, Raspberry Pi, it has its own Pi camera, a small camera. You can connect your Pi camera into this port, and using this one, you can able to see what's happening outside. So the camera can be used, and especially in the Raspberry Pi, for example, I can just tell you tell you a robot project what I did. It's like to see the people who are coming in front of you. It will detect, it will see, by seeing the face itself, it will tell who is that person, what is about him and everything. It will welcome, it will greet that person. Okay, so to do that one, I have used one library. It's an open source library I have used, which is called as the OpenCV library, which is of use, it is using HAR classifiers. So the Pi camera which is connected to it will capture the images. It can also capture it as a video. It can also capture the images. It will capture the images, and using the program what we have, OpenCV programs you can use, using that programs, it will detect the person, and if you connect a speaker over here, it will tell who is the person over there. Okay, so this is another thing. Apart from this, I have also used that PLC. If you have a knowledge in PLC, really you can go with a PLC to create or to implement a robot. That will be more useful, and it will be more accurate also for you. Okay, and some sensors, I'm giving you some sensors. This is not in an industrial level robot. This is for a student's level, a simple robots. I'm showing these sensors for you. These are compatible with Arduino and also compatible with Raspberry Pi. And this sensor, you may know, it's called as ultrasonic sensor. This is IR sensor. Okay, these sensors are used for obstacle detection. If you feel some obstacle is in front of you, you can also you can use this sensor. And down you have, which is the color sensor to understand the color, and this one is the motion sensor. If anyone is passing over or any light is passing over, you can, if you want to understand, you can use this one. And this one is the dust sensor. Actually, I used this sensor in one of my research where I implemented like to clean the solar panels using a robot. in the deserted places, a lot of solar panels are kept. And if you put some people to clean that one, it is really too hard and it is time consuming. It is also not good for a human to stay in a desert to clean all those things. So I have just developed a robot to clean the solar panel by itself whenever the dust forms. So I used a dust sensor. I use this dust sensor. So automatically the robot will comes to know from this sensor that where the dust is formed. It depends on the dust density. The robot will move to the exact location and it will clean the dust. Okay, and this is a touch sensor. Like for example, in a human, when someone touches you, you will understand that somebody touched you. So in a robot, if you want to implement the same thing, you can use the touch sensor. So if someone touch here, the robot can activate or can able to do. This is the flex grid. It will actually this will if you move your fingers, okay, accordingly, if a robot has to do something, you can use this flex sensors. And this is the heart rate sensor. Like if you put your fingertip on the top of this one, it will count. And if you have to write a program, So basically, based on that one, it will give you the number of pulse rate, this one. And this is the ECG sensor you can use. If you put these three LEDs on your chest in the designated places, you can also see the ECG in your screen, and also based on that, the robot can take. So these three robots, actually, these three sensors, especially these three sensors, I have used in one of my research project, which is called as a smart nursing assistant. It will work like a nurse to understand, to get the pulse rate, to get the ECG, and also it will understand the situation of the person. So time to time, it will give the medicine also to the person. So this one, and this is a moisture sensor to understand the moisture level of the soil. You can take this one for the agriculture related robots, and this is the rain sensor, this is the HQ sensor, gas sensor, smell sensor, this different type of sensor, and these two are the cameras you have here. And this is the camera, what I told, Raspberry Pi camera. Okay, so these are the input devices, and I think the time is flying, so I will just go a little fast. And this one is the output devices. Okay, I told about the actuator. Once you started thinking, based on the decision, the actuator has to work. So the output will be, we call these things are called as a grippers, which looks like a fingers. We call it as a grippers. In most of the industry purposes, the grippers are used to lift the object and to move. And in all the electric actuators, you will be using the different types of motors here. You can see this is a servo motor, this is a DC motor, it's a stepper motor. So different kinds of motors we are using here to operate the actuators. Okay, so these are the three different kinds of things we will use in a real-time robotics. For thinking, we'll use a type of microcontrollers or microprocessor, and for sensing, we'll use some sensors and cameras, and for acting, to implement, to complete the task, we'll use some type of motors and the grippers here. Okay, so this is all about the robots, a simple basic ideas I gave you. Okay, and in case if you have some doubts related to the robotics or how to implement, and because of the timing, I couldn't go into deep about the different implementation process. Okay, so anyhow, bear with me today. And if you have any doubts, I can help you, I can support you. Please ask me in the chat box.
Any queries from participants, please, you can ask either through chat box or unmute your microphone and you can ask to him. Sir, one of the question from Jamil sir, what is hair classifier?
HAR classifier, it is like, it's an image processing technology. Okay, it is used in image processing, when we say called as edge detection, RGB classification, same like that one. HAR classifiers, it will take the pictures of any face, it will put a window for the eyes. If you go for any places, like for a face recognition is there, so they will understand the length of their eyes, between eyes, this one, and there will be a rectangle will be formed here to understand the length of this one. So based on this one, the machine or the face recognition system will identify who is that person. Okay, so to do this one, we have an open source library called as HAR classifier. It will work accordingly. Okay.
So it's a machine learning algorithm.
Yes,
is it?
yes, 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 yes. It's a machine
Mainly for
learning.
object detection
Yes,
purpose.
yes, yes, yes.
One more question from Kavita ma'am. Many of the research they are using Arduino for doing the research in the robotics, but is it not preferable one?
Arduino is a low-level purpose only. I have used a lot of Arduinos and different kinds of Arduinos in my robotics researches, but I will never prefer Arduino when you want to go for a robotics research for a long time. For an initial stage, for an understanding purpose, you can go, but it is not that much good to go with Arduino. Why? Because I will tell you the problems you may face with Arduino. Today, the sensor will work. Okay, when you get heated, if the microcontroller is working for 2-3 hours, and if it got heated, and surely the sensors will not work according to what you want. It will change the values. This is one thing. And another thing, the clock pulse is also, it is 16 megahertz only. So you will not get the output in the time what you want. The delays will be very high there. Okay, so that is what I don't prefer it. So, but same like Arduino, it's better you can go with this one, Raspberry Pi. It's a bit difficult, but you can easily do, and things will be very easy. And also PLC is more comfortable, which is more strong and more powerful microcontroller. That's what my purpose. But if you are in my suggestion, but if you are in the beginner level, you can go with Arduino. There is no harm in that one. Okay,
okay sir. One of the questions from my side, can you able to share some of the areas of robotics for doing the research for the new researchers in the robotics area?
Very good. Okay. Really, I like that question. Okay. We think that most of our students, I believe that many people are students over here. So I just would like to open their eyes. Most of us, we will think that we have to do robots in very big ways, like this and that. Okay. Like in the space, even we have in space, we have space robotics, many things we think. But I will suggest you a very simple thing, okay, in our day-to-day life, okay, when we pass upon some place, like an agriculture farm, okay, you will see a lot of people struggling over there. They are finding it very hard to do some work there. Just implement a small solution to them using a robot. It will help the human being there. Okay, this is one of my suggestion in the agriculture. Second, another one thing also I can say, you will see a lot of people, handicapped people, those who are finding it very difficult to move from one place to another place. We are also seeing people in the bus stations, in the roadside, that they are moving in a small table with 4 wheels, and they are finding it very difficult. If you students can come with a low-cost solution like a robot, which will automatically, if you just press the button, it will automatically take the people over there. It will take to the people. This will help. Another one thing, there are people like having handicapped without one leg. Okay, they have one leg, but another leg is handicapped by any accidents or maybe by war or somehow it has been lost. So what you can do, you can create an exoskeleton robot there. So which will work like an human leg, an artificial leg. I will suggest you something, how it can be done. If you are moving, when you are walking, if there is a fire, as a human being, we will know that there is a fire, so we will not put our leg. Okay, but or if you put your leg into the fire, you will sense it immediately and you will understand that there is a fire. You will pull your legs back. Okay, and if you have an artificial leg, a normal artificial leg, if you put the leg into the fire also, that leg will not sense and it will not understand that there is a fire. But you create a robotics leg, and that leg will understand that there is a fire and it will pull the leg by itself. This is the second thing. And the third thing, again, I can tell you, lot of boys, people, those who are using motorbikes, okay, when you move on the road, you will see a hump or you will see some holes on the road. So immediately we will stop applying the brake there. When we apply the brake, we will stop it and we will take another side and we will go. Instead of you put the brake, if you keep a robotic sensor or you convert your bike into a robotic bike, when it see the hump or when it see the hole, immediately your bike will stop. Your bike should stop, it will take that by direction. So these are the day-to-day life. I'm speaking about day-to-day life. And you can implement. Once you are satisfied this one, once you could achieve something here, then move to the higher level of robotics. Now in the motion planning, path planning, intelligence, how to inbuild intelligence into the robot, there are different researches are going on. You can also go through it. Okay.
Some few of the questions are there. Is one of the question from our students, is Raspberry Pi prone to hack the robotics project?
Is Raspberry Pi
Prone to hack?
Prone to hack. It is actually, the Raspberry Pi is connected. You can connect your Raspberry Pi to the internet because it is having a Wi-Fi and it is having a network. Okay. But it is an open source software, so it is very, very rare to hack with that one. Okay. If you have secured it properly, if you did all the protection, it is very, very difficult to hack it. Okay.
Okay, sir. One more question from Noor, sir. What are the current technological development in robotics?
Current
Technological development in robotics.
Now we have actually, like in the medical side, too many developments are there. Okay, even I will tell like one thing. Now when we go to the hospital, the nurses are actually putting if you want to go for a blood checkup, the nurses are actually putting the injection on your hand and they are taking the blood and they are testing it. Now, now some robots are being implemented. Like when you go there, you put your hand there, automatically the robot will sense where the vein is there, where the nerve is there. It will inject it, it will take the blood. After 5 minutes, it will give you the message. What is your problem? What is your health condition? Everything it will say. So in the medical field, too many developments are there. This is one part. And in the same medical field, a lot of elderly people, they are in the hospitals and no one is there to care them. Okay, so in that cases also, to take care of the elderly people, to be with them, to speak to them, many robots are being developing this one. And of course in the space, okay, space robotics is also been developing too fast nowadays actually. Okay, these are the two fields I prefer. It is going too fast, but I suggest you people to go with the agriculture side, where people are finding it difficult. It is more suitable for the Indian nature also. Agriculture, like handicapped people, to serve the poor people, like that it will be more good. I prefer and I suggest you to go with this one.
And two more questions. Suggest convenient programming language support to do research in robotics.
Programming language, you can go with Python, which I am doing now. Python is a powerful programming language which can be worked with a lot of open source systems. I'm going with that one.
And last question, how long to make an autonomous car?
How long? It depends on the facilities and your expertise into that one. The way, how long, for example, if you want to make your autonomous car to follow the traffic based on the Google, what we can say, the map, the Google map, and using the geostation orbital robots, means the satellites, if you want to go, it will take, at least if you work hard and there, it will take 1 month's time if you have all the facilities. days. In 1 month, you can go with that one if you want to follow the traffic. But if not, just you want to make an autonomous car just to detect the obstacles in front of you and take the direction, and it has to move, means it will take another maybe around 3-4 days, you can finish it off. And if you want to have an autonomous car to follow a track, means in a single day, you can finish that robot also. It's from my level I am speaking, okay?
So one of the last question from the participants is all the automation application, shall we use a robotics technique? And for example, even road signal detection, shall we use the robotics?
Yeah, in the road signal detection. Now, when you say automation, okay, automation is there without intelligence also, okay. When you say automation in the road signal, now we can see that it is actually automated now, okay. Like after 3 minutes, it will switch off. After 2 minutes, it will switch off, something like that, it will change, okay. When you implement robotics there with an intelligence, so it has to define like based on the density, whether if you see now in the normal traffic signals, if there is no vehicle also, it will wait for 2 minutes there, okay, if you set the time. So you can implement a robotics techniques there, like if there is no vehicle, don't open up the door or don't open up the light for that particular road, you open up for the next road where there is more population is there. So we can implement a traffic light system using robotics also there.
Okay, thank you, sir.
Okay. Thank you.
Participants, any questions from?
Yeah, there is one last question I'm seeing. Any robotic? I would like to comment on that one. Okay, that's a very good question. Actually, I was expecting that question from someone of you. When Mr. Saki Raja has asked that question, it's a very important question. Any robotic related attack on human life, sir? It is, okay. I always suggest, actually, I wanted to tell this also. I always suggest robots, you have to do it only for the good purpose. If you take it for a wrong purpose, there are four laws of robotics. In that laws, it will say the robot should not harm any human being. Okay, if we take that robots to a wrong understanding, it will really affect the human. So it shouldn't be. All people, those who want to do any robotic researches, it should be for a constructive way. It should help the human alone. It shouldn't be go for any harm for the human. Okay.
Okay. Thank you, Sujin.
Thank you. Thank you.
So I will formally conclude the session by vote of thanks. Once again, good morning, everyone. I'm honored and lucky to have opportunity to give the vote of thanks in this occasion. I particularly like Dr. B. Bensujin's speech, where he specified the need of robotics, evolution of robotics, possibly areas to do the research in the robotics, as well as how to do the programming in robotics in the various types of robotics. In his speech, the way in which he explained this way, this was very extraordinary one. I thank very much to Dr. Bensujin, who has spent his valuable time with us. Surely it was very helpful to all the participants. Thank you, sir. I would like to thank all the participants from other colleges and universities and extend my heartfelt thank to my dear students of Ramco Institute of Technology. Finally, I again want to thank our management, principal and HOD of CSE who always support to make this webinar very successful manner. I would like to thank you again for making this session very successful. So here I shared the feedback link to you. Please kindly fill the feedback link. That is the attendance for you also. Once you have filled the feedback, you will get the e-certificates. Thank you once again. Tomorrow we are having another one nice session, Network Protocol Analyzer by 11:30. Kindly all you have to join with us. Thank you. The link will be activated for another 15 minutes. Please kindly fill the feedback link within another 15 minutes. Thank you. Thank you, Bensujin sir. Thank you to all.